This is lesson 7 from the Green Book. This will be the lesson for Thursday, October 25th, and it's called Qualitative Graphs. This is a little different from the graphs you've seen before because most graphs are going to have numbers on them, but qualitative graphs do not have numerical values. They're usually not going to be used if you need big details about something because it's just going to show the big picture of what's going on. So let's look at a couple of these examples and I think you'll see what I mean. Emily is downloading photos from her digital camera to her computer, and the table shows the percent of photos downloaded for several seconds. And guys, if you've ever downloaded something, you know this is true. It'll start off really good and then it stalls out and then it might speed up and then it slows down. So if we look at her table, you can see that there are several periods of time where the download percent did not change. So you can see right here from 4 to 6 seconds the download kind of stalled out. It stayed the same at 30%. And then again at 8 to 10 seconds it stalled out. Now the next question says, during which time period did the percent downloaded change the most? And that's going to be right here from 6 to 8 seconds. You can see there was an increase of 34%. So the reason they have you point out these periods of time in the table is so that when you look at the graph that's displayed below, it will make sense to you. This is an example of a qualitative graph. And look at what it includes. It includes labels. You have to know what the graph is showing. So we've got our time, as usual, on our independent x-axis, percent downloaded, our dependent variable on the y-axis, and you can see this is the part that represents the 4 to 6 seconds, or actually 0 to 6 seconds, or 0 to 4 seconds. Here's where it stalls out. This is the 4 to 6 seconds, and this is the 8 to 10 seconds where the percent download didn't change, because time keeps going, but the percent downloaded didn't change. So in this case, a horizontal line on the graph is going to show that the download is not progressing, it's stuck. So from 0 to 4, it was moving fine. Look at our greatest percent increase here, from 6 to 8 seconds. This line is the steepest because most of the download is happening in less time. So it makes for a steeper line. Again, the second stall out, and then it begins again after the 10-second mark. It starts back. Okay? So it says the graph above is a qualitative graph. Qualitative graphs are graphs used to represent situations that may not have numerical values or where the values are not included. So as it says, the qualitative graphs represent just the essential elements of a situation in graphical form. So if you needed big details about numbers or numerical values, this probably wouldn't be the graph for you. Let's take a look at a couple of these other examples. You can see here that this graph shows the water level in a bathtub, and they wanted you to describe the change in the water level over time. Also, I want to draw your attention to these key vocabulary words: increasing, decreasing, no change. Those are the type of words that I want you to use in your descriptions. It says at time 0, the water level in the bathtub is 0. Then the water level increases at a constant rate. This is when you turn the water on and your tub is filling up. Then, what do you do while you take your bath? You turn the water off and hopefully the water level stays the same. When you were little, it probably didn't stay the same because you splashed it all out. Hopefully you're not doing that anymore. Then when you finish your bath, you see the drain is pulled and the water level decreases at a constant rate until all the water is gone, until the water level is 0. Okay, let's take a look at this one down here. So the weather, the graph at the right displays the temperature throughout the day. So how would you describe the change in the temperature over time? First of all, I want to draw your attention to the fact that the lines in this example are straight. And notice it says it's decreasing at a constant rate. That's because your drain is only so big, and so a certain amount of water goes through it. It's not varying how much goes through it. But temperature is not quite like that. Temperature might increase quickly in the morning and then slowly in the afternoon. So it's going to be used, it's going to be shown using curved lines rather than straight lines. So if we were going to describe the temperature in this graph, we might say the temperature rises at a varied rate throughout the day, then cools off at a varied rate at night. Okay, so keep your eye on that as we go through these other examples, and you're going to watch for keywords like constant rate or steady rate or varied rate. The next page takes you through an example where you've got a tennis ball that's dropped onto the floor, and with each successive bounce it rebounds to a height less than its previous bounce until it finally comes to rest. So this would be an example where they asked you to sketch the qualitative graph to represent the situation. So you would have your labels of time and distance from the floor, and you can see that the ball falls to the floor, rebounds to the height less than the one before because it's losing that energy, and then finally it comes to rest at zero distance from the floor. Okay? Now, this is a little confusing. Don't think that your graph shows the path of the ball. It just so happens that as time passes, this is the distance from the floor that the ball has. Okay, let's look at this one. Driving. A car is traveling at a constant speed, so our graph is going to be time on the x-axis and speed on the y-axis. So if a car is traveling at a constant speed, that means it's going to be a horizontal line. The speed is not changing. And then when it comes to rest at a stoplight, it has to come all the way down to zero speed. It doesn't really say if he stopped at a steady rate or not, so really you could make this part of your graph a little curved or you could make it straight. Either one's going to be accessible. Okay? Now let's look at these that are under check your understanding. You're going to have to look at the graph and come up with a story that would match the graph. Okay, and you want to make sure you use those key vocabulary words. So look at this first graph with the flying. What I put was the airplane takes off and climbs at a constant rate. It's a straight line until it reaches its cruising altitude, and then it cruises. It flies at that altitude for a while, and then it descends at a steady rate until it lands. Okay, so because I put steady rate and constant rate, that shows straight lines. The one right beside it, about Jared and his money. You can see that Jared deposits money at a constant rate. He might be putting in $25 a week. Whatever he's doing, it's the same every time he goes to the bank because that's going up at a steady rate. And then he stops because the balance in his account stays exactly the same. And then all of a sudden he makes a large purchase because look, his balance jumps from here to here. And then it stays the same again. He's not depositing any more money. Now students ask me all the time, well, why didn't you connect that line? Well, because when you swipe that debit card or you pay that money or write that check, it doesn't come out a little bit at a time. It comes out instantaneously. So you're just going to jump down and finish your line down there where the new balance would be. Okay? Now the next couple of problems have you drawing the graph. And this next one is very tricky because you want to draw it like you think she's writing it, but you have to be careful and read it. It says that Tamer rides her bike at a steady rate, and then she coasts downhill which increases her speed at increasing rates. Y'all have done this. You've ridden your bike or your skateboard down a hill, and as you get down the hill, you get going faster and faster. So when you sketch the graph, you have to show the steady rate, which would mean at the same speed, and then as she starts to go down the hill, her speed increases quickly. Now, people want to draw it downhill because it says she's going down the hill, but you have to think to yourself, what's going on with the speed? It's increasing. Okay? Number 4 is similar to the bank account one that we just talked about. Jamal purchased the same number of action figures daily for 1 week. So that's a constant rate, isn't it? Over the next week, he sold most of them on the internet. So the graph would look like this. He's buying them at a constant rate, so he's adding to his collection. And then the next week he sells. It says over the next week. So again, this could be straight or this could be a little curved. We don't really know the rate at which he sold them. But it says he sold almost all of them. So I don't come all the way down to my x-axis because that would mean he had 0 left. So it just shows that he sold most of them. Now your assignment is going to be the rest of this packet, numbers 5 through 8. So read carefully, use your notes as a model, and we'll talk about this in class.